Hello, and welcome to this session titled Debug Faster, Debug Smarter. My name is Primož Gabrijelčič, and you can find me on Twitter under the handle the Delphi Geek or on internet at primoz.gabrijelcic.org. In this session I'll show you how to use few less known debugger features, and I'll also present few tips and tricks which may not be well known. All slides and code in this session are already available on my blog, the Delphi Geek. Just follow the link on the screen, which I'll repeat at the end of the session for your convenience. I will use Delphi for this demo, but most of the stuff will also apply to the C++ builder personality. So okay, let's start. Today's session will mostly revolve around breakpoints. We all know them and we all use them, but most of programmers stop at the simple set breakpoint, run the program, examine variables scenario. As we'll see soon, there's much more to breakpoints than that. But before we dive into the wonderful world of breakpoints, let me show you some basic stuff. This list contains most of the keyboard shortcuts that are used for debugging. Most of them are widely known, but I'd like to point to a specific combo which is mostly unknown to RAD Studio programmers, as Shift F7. It can be best described as execute the program up to the next blue dot, then stop. This can be useful when you work over code in the mixed mode, when source code and assembler are shown on the screen at the same time, or when debugging assembler routines. To effectively debug a program, you should set few project options, which can be found in the Project Options dialog. Important settings are stored in the Delphi Compiler Compiling tab. It's usually preferred to disable optimization, such as I have here. That will help you step over the code, and that will also improve watching and evaluating variables. So in other words, you will not see the infamous message variable x inaccessible here due to optimization that much, but it can still appear. You also need to turn on debug information. And if you want to step into the RTL, you also have to enable the Use Debug This Use option, which I have here for the purposes of my demo, as you'll see later. An alternative for the Use Debug This Use setting is to use the Selective Debugging Export written by Uwe Rabe. It allows you to choose specific RTL units that you want to be able to step into and to ignore others. It's a great little tool and I really recommend it. Another part of configuration that you should know about is hidden at the end of Tools Options dialog. Debugger settings are stored in the Debugger Options branch at the end of the list. I usually check Rearrange, Editor, Local Menu and Run, so that I have debugging menus available at the top of the right-click menu in Editor. I also always enable Allow Side Effects setting, so that my watches are fully functional, and I also disable Prompt to Rebuild Projects modified while debugging, because I do this manually when I want to do it. Also of interest is the event log page, where you can configure how messages are displayed in the event log window. I usually disable all kinds of messages except output messages, that is, messages generated with the output debug string functions, because I'm just not interested in them. Enough with the basics, let's deal with the breakpoints now. Each breakpoint, which you can set by pressing F5 or with the mouse, has a bunch of properties associated with it. To access properties for a breakpoint, you can right-click the breakpoint or you can use the breakpoint list window. So if I create a breakpoint with mouse or F5, I can right-click, select breakpoint properties. Or I can go to the breakpoint list, select the breakpoint and press Enter on my keyboard, which will also bring me the breakpoint properties window. The first one of those properties is enabled. Toggle it and breakpoint will stop functioning. That is, it will not break into the debugger anymore, but it will still be configured. That's very cool, as you can have all kinds of stuff configured on a breakpoint, as we'll see later. and by toggling enabled, all this configuration will stay there. If you delete and recreate a breakpoint, you have to redo all configuration from scratch. So to enable it, I can just right click and select enabled, or I can press Shift F5. The next important property is condition. In this field, you can enter an expression which must evaluate to a boolean. Only if this expression evaluates to true, the breakpoint is triggered, otherwise it is ignored. So let's see this in practice. My demo program here has a stupid loop which executes 1000 times and calls some code. And I want to stop inside this method when I is equal to 876. So I set up a breakpoint, right click, properties, and into condition I can write I is 876. OK, F9. The program will start in the debugger, and when I click the button, I find out that I have to wait quite some time before my breakpoint is triggered, but 800 something, that's not really much in computer terms. So what's going on? Well, what's going on is that on each breakpoint, the program must switch into the debugger, which is a very slow operation. And then the debugger will check the condition, see that it is false, and it will switch back to the program, which is again a slow operation. And this happens 875 times during my program, and that takes quite some time. So an alternative here is that I can rewrite my condition in code. I can say if I is 876, then break into the debugger. So how to do that? Well, I can just set a breakpoint on something. So I usually use sleep of 0 and put a breakpoint on it. If I run this now, you'll see that it breaks immediately. I is 876, and I can continue my program with F8. An alternative to this write some code and set a breakpoint combo is to use a purely programmatic approach and call the debug break function whenever we want the program to stop. So in my example, in my third function here, I could do if I is 876, then debug break. This is implemented in winapi.windows. I don't have to set a breakpoint now, but I break into assembler code, and if I press F8, I'm still in assembler, so I have to close this page, and only now I'm in my method. So I like to use my own implementation of debug break, which you'll find in the code for this session, and it also allows me to put this condition inside, so I don't need 2 lines, I only have 1 line. It will automatically disable itself if the debugger is not attached, and it will automatically disable if you compile in release mode instead of in debug. It's still very quick, and also I'm now in Pascal. I can press F8 and I'm in my code. Let's move on. The third important property is pass count. With it we can specify how many times the breakpoint is skipped before it is triggered. If we set pass count, for example, to 100, the debugger will skip it 99 times, and only then the breakpoint will break. As with condition, this slows down execution. But still, this property can be very helpful, especially if we want to find out how many times our program passes through some part of the code before something else happens. For example, before it crashes. Let's see this in a demo. I have here a specially prepared program which doesn't start. I get runtime error 217 when I try to run it. If I try to go in with F8 and then again F8, I'll see that something goes wrong during initialization. This is in system units. I have my debug DCU turned on, so that's why you see this code. And something goes wrong here. I could, for example, try to put a breakpoint here, but I'll immediately see that even in my small program there are 180 initialization methods, initialization blocks. So if I go with F8 through all these, I will spend quite some time pressing the F8 button. An alternative is to put a breakpoint here and say only break after some very large number of repetitions, which will not be reached. Press F9, and when program crashes I can check my breakpoint list and see, okay, this breakpoint triggered 177 times and then we got an error. So I can just fix my pass count now to 177 and stop the program, Ctrl F2, F9, and now let's see, my initialization code is called here, so if I press F7, oh yeah, I forgot my debugging code inside. Let's fix that. Besides these basic but interesting properties, each breakpoint can execute some side effects. For example, you can log a message when a breakpoint is reached. You can evaluate and log an expression. You can even log call stack, which brought you to this point, and more. The interesting part here is that you can configure the breakpoint not to break. In other words, not to stop execution and switch to the debugger. So you just get side effects, so you can dynamically add logging to your program this way. So for my demo, I have here evaluate button, which sometimes, but not always, causes an error. Here it is, floating divide by 0. Let's see what's going on. So something is passed to some function, but I cannot evaluate this expression, the parameter. It's quite typical behavior after an exception. And let's say I don't have the source for this, do some magic function. So what can I do? Well, I can log out value.value to see what's going into the function before it crashes. In advanced part of the breakpoint properties, I can log my expression. I can only log string expressions, so I have to convert my integer value to a string. I have to check log results, and I will uncheck break because I really don't want my program to stop here each time this function is called. If I run now, I click the evaluate button and you can watch the event log window down below. Oh, that was quick. Let's do it again. As you can see, logging takes quite some time, so again the program executes much slower than without the debugger or without the breakpoint. One of the ways to fix that is to use output debug string to output my value. I have a macro for that because I use it quite often. This will also write a value to the event log window, but it will execute faster than a side effect of a breakpoint. If I want even a faster speed, I could, for example, use some third-party logger, or I can log everything to a console window. I could just use the simple, old-school write-line function. And I don't even have to call integer to string, as write-line knows how to handle integers. But I have to do something else. I have to create my console window before this is called. I have to call allocate console function from Windows unit. If I run this now, I will rearrange my windows a bit, so I will be able to see what's going on. I will click log to console, and as you could see, numbers are output really fast. And now we got our error. The interesting fact about the eval side effect is that it doesn't have to return anything. It doesn't have to return a string. That means that we can execute any part of code, any method inside our breakpoint. For the demo, let's say I'm running this program here. It stopped at my breakpoint, line 228, and I would like to write the value of string s into a file after show message will be called. And I don't want to stop my program or change the code or anything. What I can do, because I have a nicely prepared function log string here, I can set up a breakpoint and go to properties. Of course, disable break as always, and into eval expression field I can enter log string of the value I want to log, s, no semicolon, and I can also uncheck log result because I don't want anything to be displayed into the event log window. I just want variable to be saved into a file. And if I now continue execution with F9, press OK, switch back to the editor, we see that my file was modified and the value was written into it. This is very powerful but also very tricky, because if this function is not compiled into a program, which typically happens if a linker removes it because it is not used anywhere, this breakpoint will just be silently ignored. So in this example, I did prepare everything nicely. I have here a function, I have here a code which accesses the log string function so that it cannot be optimized out, and I'm also calling this helper method don't optimize, which in this case just removes the hint variable p is not used. So this is very simple function. It does nothing, it just tricks the compiler not to display the error. If I remove this code and rerun, everything works, no errors anywhere, but my file was not modified at all. I still only have the previous value inside. What's going on? If I check this log result here, we'll see what happens. So run again. And now we see in the event log window that the function log string was eliminated by linker because it's not used in the program anywhere. So usually you will not be able to use this trick without a bit of a preparation ahead, but once everything is set up, this can be very powerful. The next topic I want to talk about are breakpoint groups. You can put a breakpoint into a group, or you can put multiple breakpoints into a same group. And you can then enable or disable the group manually or through side effects of another breakpoint. And this is especially useful when you don't want a breakpoint to be triggered every time, but only when it is reached to some specific path in the program. To demo breakpoint groups, I will continue my example from previous demo. This test groups method, we already know that it is called from two different methods, from test groups intermediate 1 and test groups intermediate 2. Now I want to set up this breakpoint test groups so that it will be only triggered when test groups is called from this second function, from intermediate 2, and not when it is triggered from the first function, from intermediate 1. If I just put a breakpoint and run, I will see that it was called from test group intermediate 1, not from intermediate 2. So let's fix this by using breakpoint groups. First, I will put my breakpoint into a group. Let's call this the test group. Then I will make sure that at the beginning this group is disabled. So we'll put here a breakpoint with side effect, and side effect will be disable group, test group. Then inside test group intermediate 2, I will add two breakpoints. First we'll say when reached, enable my test group, and the second will do the cleanup. As you can see, I need to do quite some work, set up 4 breakpoints for the price of 1. But now when I execute the program, I see that my code was called from test groups intermediate 2, which is what I wanted to achieve. When debugging multi-threaded programs, we sometimes want to limit the debugging session to only one thread. One example is stepping through the code. When we do that, we only want F8 or F7 to work on the current thread, not to step into other threads, which may become active. Another example is when some code is called from more than one thread, and we want to put into it a breakpoint which is only activated from one thread and not from other threads. So let's see this in a demo. I have here a code which creates some thread, anonymous thread, and starts the thread. And this function calls in a loop 100 times. It's a stupid code, it's a demo code. Check something. Okay, so if I put a breakpoint here and press F9, let's see what happens. Oh, my breakpoint is immediately activated. So why does this happen? Yeah, because it's also activated, it's also called from some other thread, from the main thread via application on idle event. And well, that's of course a very, very bad design. But I want to debug this to see what's going on, to fix my design. And I want to, for example, only trigger this breakpoint when this is called from my thread. So one way I can do that is to stop this breakpoint, put a breakpoint in my thread, run. And then I have to check what's the ID of my thread, 16,320. Now I can put a breakpoint here, set up a condition, and I will say please only execute when called from this thread, 16,320. If I run this now, we'll see that it was indeed called from thread procs, not from idle. This is inconvenient, having to find the true name of a thread, having to find the true ID of a thread. So I can do something else. I can, for example, name my thread here. I can say tthread dot name thread for debugging. demo thread. If I put now a breakpoint here, put breakpoint here, I'll see that my thread now has a name, so it's easier to find it. Oh, now if I want to limit my debugging at this point to our demo thread, I would go to thread status window, right click, and freeze all other threads. So all threads, but not this one. I can now freely press F8, debug around, and test my code, and application on idle will not be activated in the meantime. When I'm satisfied and I want to continue, I have to right click again and say tow all threads. So this will reactivate all other threads. Now I can press F9. Well, my breakpoint is still active. Yes, it's still filtered. If I remove this condition, it will be called immediately from the onIdle event handler. So when you debug threads and you freeze threads, always remember to tow them afterwards. When an exception occurs in a program, debugger pops up. You already know that, I'm sure. This can be quite annoying sometimes. Luckily, there are at least 3 ways to disable this behavior in Delphi. We can add the exception to the list of ignored exceptions, or we can ignore exception with a breakpoint side effect, or we can use a little known trick and modify the exception class variable. And we'll see all 3 approaches now in example. I have here a code which raises my custom exception, myException. If I run it, I will get a breakpoint in the debugger. Then if I continue, I will see nothing because this exception is handled in my code. So I really don't like debugger to pop up because I know I'm handling this exception. So what I can do, I can add it to the list of ignored exception. I can check the ignore this exception type, continue, and now when I click, nothing happens anymore. To remove this exception from the list of ignored exceptions, I have to go to the debugging options. I can just press Ctrl dot and type debugging and go to debugger options page. And here is on Embarcadero debuggers, there's a language exceptions subnode which contains all exceptions that are to be ignored. I can remove my exception here, deactivate it or remove it fully. And now if I press F9, it will again break into the debugger. As I said, my other option is to use a side effect. I cannot disable only one exception type with side effect, but I can ignore all exceptions after this point. And of course, it's very good if I remember to clean up, to reactivate exceptions back at the end. Now again, nothing happens because my side effect disables exception handling. And the third approach is to change the exception class variable. This is a global variable which contains by default type exception, and Delphi or RADStudio debugger will only break on exceptions that are inherited from the current content of the exception class variable. Since all exceptions are inherited from exception, these typically, all those exceptions trigger the debugger. But if I change the exception class to something, and I cannot change it to nil, this doesn't work, but let's say I will change it to some unused exception, which I don't really have. I'll just make it up on the spot. I'll store this away. It is of type T class. I will restore it at the end. And now if I run this second code, you'll also see that nothing happens. And just to prove that I'm really executing this, I can comment out this assignment. And my breakpoint will trigger the debugger. In addition to software breakpoints, which always slow down execution of a program, RadStudio supports hardware breakpoints, which are implemented inside the Intel processor. There are two kinds of hardware breakpoints, address and data. Address breakpoints are similar to normal breakpoints, but they can be very useful when you want to set them on a code which exists in a read-only memory. Because software breakpoints mechanism requires the debugger to modify the code during runtime to set the breakpoint, and hardware breakpoints, well, doesn't. Data breakpoints are even more interesting. They are triggered when a value in memory is modified. This is incredibly useful when you want to find out why some variable is changing its value when it shouldn't have. Two downsides of hardware breakpoints are that you can only set 4 of them, and that they are automatically disabled on program restart, so you have to reset them. Which makes sense actually, as they are connected to a memory address of some entity, and that can change when a program is restarted. For a demo, I have here a code which creates a test object with some value, calls run function, and then checks a post condition. We know that value field of this test object should be 1 at this point. As we'll see, this doesn't happen. Yeah, okay. And this value is assigned here in the constructor, but then it's changed in real program. It would be changed at many places. It would be hard to find all those places. So what can we do here to find out when this value is modified? Let's see. I'll put a breakpoint here, just a normal breakpoint. Click the button, and now we'll see. Now it contains 1. That's fine. Now let's set a hardware breakpoint. Here in the breakpoint list, I can click the arrow and say add data breakpoint, or I can right click and say breakpoints, add data breakpoint. And I want this breakpoint to trigger when f value changes, so I have to put in an address of this value. RadStudio is kind enough to calculate it for me. I have to put in length 1, 2, 4 or 8 bytes. 4 is okay because this is an integer. I can set some other conditions and such. I will not do that. Okay, now I will press F9 and we'll see, oh, we are modifying our value here. Indeed. And as you can see, we read this value 4 times, which didn't trigger a breakpoint, and then we modified it and the breakpoint got triggered after this modification. So value is firstly changed in memory, and secondly the debugger pops up. That's just how it works. Incredibly useful when you are looking for weird stuff which shouldn't be going on but is. At the end of this session, let me show some nice features of the debugger which I personally like a lot. One of them is run until return, or shift F8. Let's say we have this code. Show message, append string, OK. I click the button, stop at the breakpoint. I want to go into append string, so I press F7. Oh, I have debug DCUs turned on, damn it. So I have to press F8. F8. Oh, there's another function, F8. F8. Oh, and I missed. I should press F7 here. I missed my append string. A better way, when I found myself in assembler or something like that, I can press Shift F8, which executes everything up to the return. Then I can press F7 again, and I am now inside my append string. The second thing I want to mention is that you can move breakpoints around with the mouse. So if I have a breakpoint here, let's say this one, I can grab it and move it to a different place in code. And that's especially useful when I want to move breakpoint around but keep all side effects that are configured for it, because everything will stay the same. I can see if I go to right-click breakpoint properties, I have this line number field here which is disabled, so I cannot change it here. But interestingly, if I go to breakpoint list, that was 121, and I press enter here, now I can change my line number. I can put it to 123. And my breakpoint moves. Now, something similar I can do with the current execution point in the program. That, of course, I can only do when program is stopped, typically when I reach a breakpoint or when I step around the program. And that's very useful when you want to repeat something. For example, before I clicked return for method, then we pressed F7 and F8, 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 and we missed the append string. And if I want to repeat that, I can just grab blue arrow and pull it up. Or I can right click and say, well, I have to right click not on the red button. I can say set next statement, which will also move my blue dot around. And now I can press F7 and do this again. Shift F8, F7, okay, I can now see it. Of course, this doesn't work every time. If my code modified global state, then next time I execute it, something different may happen. I cannot go out of scope with this, so if I try to go inside or outside try except blocks or something similar, outside methods, inside methods, everything will break. But it works great for repeating the last statement, which you just missed because you pressed F8 instead of F7 or something. Next trick are call stack breakpoints. Let's say unexpectedly a message dialog pops up in my application. I want to see which part of the code triggered it, so I can just pause the program, and then I have to switch to main thread, because when I pause, a special debugger thread is activated. Here at the end, I have to go to main thread. Then I can find the code which called my show message. That was here. and I can put a breakpoint here. Or alternatively, I can just right click here and say toggle breakpoint or press F5. And now I have a breakpoint on a call stack, and it also appeared here in the code, as you can see. And now if I continue execution, click OK, my program will stop at this point. And for the Rust tip, I just want to mention something that's not obvious to all of us. Even I forget from time to time that this function exists. When you debug a program and want to run it without debugging to the end, the easiest things to do is to go to the breakpoint list and click here, disable all breakpoints. And now everything will continue as fast as possible. Of course, I can enable breakpoints back. I got this error because I cannot set up my data breakpoint, which is still in the list. And I can also delete all my breakpoints. Use it with care because you cannot undo that. That concludes our tour for today. Thanks for listening, and if you have any questions, now is a good time to ask.
Have you used the custom code for, yep, okay, you shared that, the custom code for debug break. That's up on your blog post, right?
Sorry, what was the question?
The custom code for debug break function?
Yeah. It's in the code, which is available at this link. So
okay,
it's very small routine. You can use it anywhere.
I used to have a similar, I had a debug break, custom debug break I wrote a while ago, but it's useful to have that. Actually, yours looks better than the one I had. Lots of people saying thank you, lots of things they didn't know they could do. Do the tips also work in C++ Builder, or are some of them specific to Delphi?
I think they should all work in C++ Builder. I didn't really check, but nothing here was language specific, and I think Red Studio supports all that stuff on both personalities.
Okay. How to set data breakpoints? Did you go over that?
Yeah, there was a short example, yes.
And what can you remind me real quick the steps for that?
So basically you did, let me open some project in my Delphi. I don't know such stuff out of my head, never.
I know, I'm the same way. It's like, I know I got to go someplace over here.
You can go to breakpoint list window and click the small black arrow next to the add breakpoint button, and you'll get a short menu which says source breakpoint, data breakpoint, address breakpoint, and you can add it there. It's probably the simplest thing. Another is to right click in the breakpoint list view, and you have then add submenu with same items.
Okay, great. So Johanna's saying that occasionally the blue dots get out of alignment with the code, and wondering if you have any tips on how to get them lined back up.
In my experience, blue dots get unaligned when you copy paste code from the web, because under some, I don't know what circumstances, Red Studio will then paste in line delimiters in Unix standards, so only line fit, no carriage return. And if that happens, editor works correctly, but the part of the code which counts lines and display dots only handles carriage return line feed, not line feed. And that's usually the reason for blue codes being misaligned. I usually copy the problematic unit to Notepad and save from Notepad to the disk, because Notepad will correct that stuff.
Interesting. I've seen that occasionally, and I never put the two and two together, but that could be occasionally I would do copy bits of code from the web. That's interesting. You know what? Actually, someone ought to put a bug in on that if it has quality.embarcadero opened, and with that deep tip, because maybe that's what we need to fix.
That's an old feature of Delphi, at least. I don't know about C++ Builder, but I never saw it really in action in past, I don't know, 3-4 versions, so I don't know what's the current status of this problem.
Okay.
Definitely happened a lot in older Delphis.
So here's a question about output debug string, if that works on other platforms, or is that a Windows-specific feature?
Output debug string is Windows-specific feature. I think there's another session on logging on all platforms on CodeRageXI.
Yep. Brian did one on, Brian Long did one, he said use log D.
Hmm.
And that works on all of them. Where is the log folder located?
What log folder? There's no such concept as a log folder.
Yeah, I didn't think so.
Event log messages are only stored in memory while the Rad Studio is running, and when you save them, you specify the folder for them.
Do you have any performance tips on Win64 debugging?
No. Sorry. It's a remote debugger running on a local machine, so you cannot optimize the connection between the two parts. It's already at the maximum, so I think with the Win64 debugger, what you get is what you get. You don't have much options to improve the performance. But I don't have much experience with these debuggers, so
Yeah. Okay.
much to add here.
Russ added that his experience when if he edits the code while debugging, then it misaligns the blue dots. But usually in that case, that when you recompile, it fixes
Of
that.
course, that's but recompile will fix that. I was talking more about the problem where you can compile as much as you want, but blue dots won't be correctly aligned.
Yeah. Okay. Well, I think that's it. Lots of people saying that they're looking forward to seeing the replay again, and following up on your blog post to get some more information. Lots of great useful tips in there. That's fantastic. Thank you so much.
Yeah, thanks.